How many ways are there for 5 couples to sit in 10 seats next to each other such that each person is sitting next to their partner? Okay, now how are we going to do this? Let's just jump right into it. So there are 5 couples. This is one of the most important numbers in this. So as soon as I hear this 5, I'm going to draw 5 seats. Even though the question says 10 seats, but you'll understand why I have 5 seats later. Each couple has to be sitting next to each other. So I'm going to assume that each couple is one person, because I know that I can assume that each couple to be a whole because they're sitting next to each other. So then I can just use some normal combinatorics techniques. I can say that this number is going to be 5 factorial. I'll tell you why. Let's say that there are 5 couples. There are 5 couples and they're named A, B, C, D, and E. Now for A, my A can either be here, 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 or here. So that is 5 possibilities. Now my B, if let's say there's already 1 spot taken up, so my B can be in 4 spots. Let's say A has been here, so B can be either here, 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 or here. So that's 4. Now this goes on all the way until E, and it ends up being 5 for A, times 4 for B, times 3 for C, 2 for D, and 1 for E. Now, if you know what factorial is, we know that this is the same thing as 5 with an exclamation point. So we have 5 factorial. Is this the answer? Is 120 our answer? No, because there are ways inside each couple. So let's say that this is a couple. The name of the boy is Alex. And the name of the girl is, let's say, Carly. So we can have Alex and Carly sitting like this, or we can have them the other way. Sorry, man. We can have them sitting like this. Carly and Alex. So in each couple, there are 2 ways. So we have our 5 factorial. Now this times 2 to the power 5. Because for this couple, I have 2 ways, times 2 ways, times 2 ways, times 2 ways, times 2 ways. Now this number is 2 to the power 5, which is 32. So now after this 5 factorial, then I have 32 ways to arrange each of these couples, each of the people inside the couple. So then we have 5 factorial times 2 to the power 5. And doing some quick mental math, we get the answer to be 3,840. Now, there is another way to do this. One that one that requires less steps. So here's how we're going to do this. Now we're going to assume that there are 10 seats. Fine, let me just draw 10 seats. 5, 6, 7, 8, 9, 10. All right. So 1 second, let me just make this one a little better. 10. All right. So now, for this seat, I have 10 possibilities, 10 people. Now, for this seat, I know that these 2 have to be in a couple. So if there is a person here, then there's only one corresponding person that goes with this person. So there's only one possibility here. Now for this one, there are already 2 taken up. So now we have 8 people left. We have 1 here. Now we have 6 here. We have 1, 4, 1, 2 people, and then our last person. So now we are just going to multiply all of these together. And now let's multiply it out. We get 10 times 8 is 80. We get 6 times 4 is 24. Also, I'm leaving all these ones out because we don't need them. They're just multiplied by 1. And we get 2. So 80 times 24 times 2. Now let's do 24 times 8. We get 2, 3. We get a 16 here and a 19. So 192 followed by 0 times 2. Now we get this to be 3,840. And we get our answer again. So basically what we did was 10 double factorial. So this is a notation whenever our first number is n. So let's say I have n double factorial. Basically what this is that it is n times n minus 2 times n minus 4, sorry, my bad, times n minus 4 times n minus 6, and so on until we reach either, our last number can be either 1 or 2, depending on whether n is odd or even. So those are 2 ways to do this problem, and yeah, that is an answer.